continuing on with our domain symbolically lesson, if you practice these, you saw some of these are a lot harder than the previous ones. So we're expanding on this knowledge, but here we saw a radical restriction. So if I describe what's going on here, inside of the radical has to be greater than or equal to 0. Well, that inside is 7 minus 2x, and it's greater than or equal to 0. But if I'm solving, you could do it in a few ways. I'm going to go ahead and subtract 7. That would give me negative 2x is greater than or equal to negative 7. And then divide by negative 2. And when I divide by negative, that flips our inequality sign. So hopefully that's an algebra solving method that you are familiar with. But if it's not, just remind yourself that when solving an inequality, I'll just write it off here to the side. So when solving inequalities, comma, all right, if you multiply or divide by a negative, it flips the inequality sign. So I'd have to be dividing by a negative 2. If I divided by positive 2, it wouldn't do anything. But flipping the inequality sign makes this now negative 7 divided by negative 2 is a positive 7 over 2. So 7 halves. Leave it in fraction form. This interval notation, if you drew on a number line, I'd find where 7 halves is. And that's okay for now. We know it would be a solid circle, but x is less than or equal to, which means I'm now shading to the left. Now our domain would be parentheses negative infinity all the way to 7 halves with a bracket. Okay, in number 4, we see 2 restrictions. So our first restriction is on top. Normally there's not a restriction for a numerator, but it's because there is a radical inside the numerator. So the inside of the radical has to be greater than or equal to 0. And we have a second restriction. The denominator cannot equal 0. So those 2 restrictions would tell me x plus 2 has to be greater than or equal to 0, and x minus 5 cannot equal 0. Let's solve that out. So x is greater than or equal to negative 2, and x cannot equal positive 5. You drew that number line. Let me find negative 2 and put a solid circle here. And I'm shading to the right because it's all the values greater, but once we get to 5, it's an open circle. So we can't fill that in, it's not equal to 5. Our domain would say bracket negative 2 all the way to 5, union 5 to infinity. Now we look at number 5, and it looks like kind of a trick question, because this is a cube root, and cube roots have no restrictions. So cube roots have no domain restrictions because of the parent function. So if you remember what the cube root graph looked like, it keeps going on forever. It didn't have any domain restriction, which means our domain is all real numbers, or negative infinity to positive infinity. Number 6, we have one domain restriction, which said that the denominator cannot equal 0. So anytime we saw a fraction with x in the denominator, that tells us one of the restrictions. And then I look to see, is there a radical restriction? There are no radicals in this problem. So it's just the x in the denominator issue. So x and x minus 2 cannot equal 0. There's our denominator. Because this is something with multiple values, this is a factoring kind of problem. This is already in factored form, but there are two possible cases. It could be that x cannot be 0 and x minus 2 cannot be 0, just because this is multiplied together. And so that's using our product rule property here. So if x was not equal to 0, there's nothing to solve, but x cannot equal 2. And so on a number line, we'd have an open circle at 0 and at positive 2. We can shade all of the other values besides those two. Our domain would look like negative infinity all the way to 0. And then 0 to 2 union, and then 2 to infinity. So there are two exclusions. 0 is an exclusion, 2 is an exclusion. All right. Number 7 forces us to use our factoring skills. So again, we have that denominator issue. All right, so if this denominator is a quadratic, then we will need to factor it. If factoring is a skill that you're not familiar with, or it's something you want to brush up on, there are some other videos about how to factor, but I would need to take this and put it into our two binomials of factors. So just to kind of briefly recap, x squared we got from multiplying x times x. So this is where we would have been multiplying the two binomials. The last term, negative 12, came from the last terms of our binomials. So we want factors of negative 12. And those are going to be 4 and 3. 4 times 3 will give me 12. We know that one of them is going to have to be negative to give us a negative 12. But the middle term, 1x, came from combining the outside and inside. So if I wanted a positive x, we need a positive 4 and a negative 3. So we factored this. Again, if factoring is something you want to review, go back to one of those other videos. But for now, we're just using that zero product property. So x plus 4 cannot equal 0, and x minus 3 cannot equal 0. Then I solve x cannot equal negative 4, x cannot equal positive 3. On a number line, that looks like, here's our negative 4, open circle. Here's our positive 3, open circle. Everything else is shaded. So our domain says negative infinity up until negative 4, union, negative 4 up to 3, union, 3 to infinity. Our last example here has a radical restriction. That's one of the first things I noticed because it is an even index, but it's also in the denominator. So we can say the inside of the radical has to be greater than or equal to 0, and so plus the denominator cannot equal 0. When I combine both of those, that means that x minus 5 is going to be just greater than 0. So you do have to use some of those critical thinking skills, but x is greater than positive 5 when we solve for x. On number line, again, that would be a 5 with an open circle, and shaded to the right, x is greater than 5. So our domain is parentheses 5 all the way to infinity. In the last video, we'll look at how to create a function if we're given a specific domain.